Since that's been
Hello, everyone. Welcome back to week 3 with programming C++ language. We are coming to dive in important concept today. We are going to explore some of the most powerful features of C++ that will help you become a better programmer, a good programmer. Don't worry if this concept seems challenging at first. We will break everything down step by step today. Well, today our learning objectives. For part 1, we have pointers, arrays, structures, and union. But I'm going to tackle with pointers and arrays for the first part, and the second part we deal with the structures and union. We will start by looking at where we will cover today. But we will understand the pointers, which are special variables that store memory addresses instead of actual values. You think of them like street addresses that tell you where to find a house. That are the pointers. And for the arrays, this let you store multiple values. This let you store multiple values of the same type in one place, like having a row of lockers where each locker can hold one item. Then you see how pointers and arrays work together. This is how or where things get really interesting and powerful. Then finally, we cover reference. These are like nicknames for the variables that let you work with the original data directly. And the second part will be the structures and union. Now let's dive in. We are beginning with pointers. When we say pointers, what are pointers? Or what's a pointer? Imagine you have a piece of paper with someone's home address written on it. The paper doesn't contain the actual house, but it tells you exactly where to find it. That's how a pointer works. Pointer works the same way. It's a variable that stores the address of another variable in your computer's memory. So a pointer is a variable that stores the address of another variable. They can be used with any data type. Pointers can be used with any data type. Instead of storing the actual value, it stores the location where that value can be found. So pointers can be used with any data types like integers, characters, floating point numbers, or even other pointers. This makes them incredibly versatile and powerful. So creating pointers. A pointer is similar to creating another variable or any other variable, but we use a special symbol called the asterisk. It's a special symbol called the asterisk. So the basic structure when creating the pointer, we use the data type, which is the integer, which is the int, bool, float. Then we bring your asterisk. Let me do an example here. So you bring your integer like this, and bring your asterisk sign, then ptr, then you declare the pointer. So this declaration of the pointer. So the pointer is called ptr. This pointer is called ptr. So it can store the address of any integer variable. The asterisk tells the compiler that the ptr is a pointer and not a regular integer variable. So we've declared the pointer here. We've declared the pointer and the structure, as I said, this is the data type. You bring the asterisk, then you bring your ptr as the pointer, of course. Now let's continue to assigning address to the pointers. The address of operator, we use the what's the name of this sign? Is it ampersand symbol? Yeah. Let's say we have an integer like you have an integer int. Oh, sorry. Let me comment on this. Let's say we have an integer int val equal to 25 like this. To make our pointer point to this variable, we write it this way. It will be like int star ptr, then bring our equal to sign, bring our ampersand. ampersand, then we enter the vowel here. We will enter the vowel here like this. Ampersand, then we enter the vowel. Then to output this, can bring the C out. We bring your C out. Value here. Can say hello here. Okay. Then here you type the star. Where's our star? PTR. PTR here. Star PTR here. Or sorry, this is the vowel. And bring the vowel here. Let's run the code and see what's happening. Error. Okay. There's no error. We have hello 25 here. Hello 25 here. It's output. So let's clear this here. So now let's remove the hello and let's run it. Okay, so now we have 25 here. As you can see, this is the output. The output is 25. As you can all see, 25. So our code is running 25. Let me comment on this and also comment on this. We are moving to dereferencing a pointer. But before that, you should take note that the ampersand gets the memory address of the variable, which is the vowel. We use vowel in our example, and we store that address in our pointer as PTR. Now the PTR knows exactly where to find the value 25 in our memory. Now let's move to dereferencing a pointer. Dereferencing a pointer is the process of accessing the actual value that a pointer points to. That's the dereferencing a pointer. The process of accessing the value present at the memory address pointed by the pointer. Dereferencing a pointer. So let's do a practical example here. It will be like int asterisk, where's asterisk? PTR with equal to this get ever like this. You come to see out PTR. Yeah, let's run our code and see. Let's run this code and see. Okay, what was the error here? Error here, I'm coming. Said var was not declared in this scope. Okay, so this is an example. This is a different example as int num equal to 42 here. Num is equal to 42 here. Then we have int PTR that's also equal to this. Where's the ampersand? Yeah, ampersand. And bring num here. And bring such an example here. And we now run our code and see what will be the output. Yeah, so it's an output here 42. So the output here is 42. The output here is 42. You've seen the output. The output is 42. I'll show how. The output here is 42. Output is 42. So now let's continue to modifying a pointer. Modifying a pointer. A pointer can be modified to point another address if it's of the same type. A pointer can be modified to point to another address if it's of the same type. So, for practical example, one of the powerful features of the pointers is that you can change what they point to as long as the new variable is of the same type. You can reassign the pointer. So let's do an example here. Not a big deal. Let's comment on this. We will deal with integer int a equal to 5, bring our comma, then b equal to 10, then we terminate, then we come down and be like int star ptr equal to percent a, and close this. So when there it is, this side points to a, this side points to a, then you print cout ptr. The cout ptr will be the same thing, then run our code. Going to see. So we see we have 5 here. We have 5 here. Now let's modify the pointer. Let's modify the pointer here. When modifying the pointer, you will be like, you come down here, then int, come down here, modifying the ptr, then so ptr equal to this, and bring b. For here, we are pointing these points to b. So we see out this ptr again, end line again, and run our code and see. Yeah, you see now our code is pointing to 10, but we didn't clear up this, so let's clear up this again. So let me comment on that. Oh, sorry, I didn't close this page. You stop it, okay. So now is our C page like this. We are running. Oh, it's refreshing. As it's refreshing, let's continue with the data sizes of pointers. Let's continue with data sizes of pointers. So for the data sizes, equal data size of all pointers are based on your operating system and your CPU architecture. Some will say the computer's architecture. All pointers are the same size, regardless of what type of data they point to. Either is an integer or a character. They are all the same size. This is because they all store memory addresses and all addresses are the same size. So here the size of the computer's architecture. The size of the pointer depends on your computer's architecture. That's your CPU and your operating system. So we have on the 64-bit system, we have 8 bytes, and on the 32-bit system, we have the 4 bytes. So whether you have a pointer to an integer, character or double, they all take up the same amount of memory. They all take up the same amount of memory.